Okay, so this is from Mastering Physics Chapter 16, and this is the problem called air bubble rising in a lake. So the problem is this. You have a diver named Jacques. He observes a bubble of air rising from the bottom of a lake, where the absolute pressure is 3.5 atmospheres, to the surface, where the pressure is 1 atmosphere. The temperature at the bottom is 4 degrees Celsius, and the temperature at the surface is 23 degrees Celsius. What's the ratio of the volume of the bubble as it reaches the surface to its volume at the bottom? Would it be safe for Jacques to hold his breath while ascending from the bottom of the lake to the surface? So I've drawn just a really simple picture so that I can write down my knowns and unknowns, and my expectation is if the pressure is decreasing, that the volume would increase. That's my expectation, knowing the ideal gas law, and that less pressure should lead to an increase in volume. Okay, so one thing I did do right away is I converted my temperatures from Celsius to Kelvin. So 23 degrees Celsius at the surface is 296.15 Kelvin. At the bottom, 4 degrees Celsius is 277.15 Kelvin. Okay, so if we start with the ideal gas law, we know that volume from the ideal gas law is equal to nRT over P. So if we're going to take the ratio of the volume at the surface to the volume at the bottom, that's nRT surface divided by P surface all over nRT bottom divided by P bottom. N and R go away, and then we have in the numerator T surface, in the denominator T bottom, and then because the P surface is in the denominator here, you're going to have P surface in the bottom and P bottom in the top new part of the fraction. So you have T surface times P bottom divided by T bottom times P surface. Just a little algebra there. And we know all of those things, right? So if we plug in, T surface is 296.15 Kelvin, T bottom is 277.15 Kelvin. Now, P bottom over P surface, well, I didn't actually convert from atmospheres because we're just going to end up taking the ratio anyway. And the ratio of 3.5 to 1 is just 3.5. So just multiply by the ratio, and you end up getting 3.74. So that means the volume at the surface to the volume of the bottom, this bubble that rises, is 3.74. Another way you can write that, V surface, the volume of the bubble at the surface, is 3.74 times the volume it had at the bottom. So they ask us this question: would it be safe for Jacques to hold his breath while ascending from the bottom of the lake to the surface? And the answer is no. It would not be safe because, let's say Jacques were holding his breath and he came to the surface. What would happen? His lungs would have to expand by 3.74 times to contain the volume of air that would be expanding as he rose to the surface. Now, another possible thing that could happen is what we call the bends. So if he were to come to the surface, while he were ascending to the surface, the nitrogen dissolved in his blood could form into small bubbles, and that could be very dangerous and causes this medical condition known as the bends.